Hey everyone, today I'm going to be going over the legal question, find peak element. First, let's read the question. A peak element is an element that is strictly greater than its neighbors. Given a zero index array, integer array nums, find a peak element and return its index. If the array contains multiple peaks, return the index to any of the peaks. And you can imagine that all elements outside of the array have a value of negative infinity. In other words, an element is always considered to be strictly greater than a neighbor that is outside the array. So for example, let's look at this array. In this case, 3 will be a peak element because the element to its left has a value of negative infinity, since 3 is the first element of the array, and it's also bigger than its right neighboring element. 1 here will not be a peak element because even though it's greater than the element to its right, which is minus infinity, since 1 is the last element of the array, it's smaller than 2. And it says that you must write an algorithm that runs in O of log n time. And one more thing is that here, it says that no two consecutive elements can have the same value. So in this case, since we're dealing with an array and they ask for O of log n time, it's usually going to be binary search. So we're going to use a modified binary search solution for this. So just like binary search, we're going to have a left pointer and a right pointer. And we're going to have, from those two pointers, we're going to have a middle index value. If that middle index value is a peak, which is a peak element, which means that it's strictly greater than both of its left and right neighbors, then we return that index. Now here's where the modified part comes in. In order to know whether or not to whether to go to the left half of the array or the right half of the array, here's what we're gonna do. We're gonna see which one of its neighbors, the middle element's neighbors, is greater than it. If the left neighboring element is greater than our middle target or middle element, then we go with the left half. If the right neighboring element is greater, then we check the right half. So for example, let's look at this. Our middle element is 3. It's not a peak element because it's less than 5. In this case, because 5 is greater than 3, we check the right half. Now, if you reverse it and we have something like this, again, 3 is not a peak element because it's less than 5. But in this case, the left element is bigger than 3. So we check the left half. There's two edge cases. The first edge case is if nums has only one element. In that case, you just return 0. Because we know that all elements inside the array are strictly greater than all elements outside the array. And the second edge case is that the peak, well, a peak is either one of the first or last elements. In that case, what we can do is we just check for both the first and last element. For the first element, we just have to check if it's greater than its right neighboring element. And for the last element, we check to see if it's greater than the element before it. So let me do the coding now. So like I said before, we're going to have a left pointer and a right pointer. And we're going to check our first edge case. So if len nums is equals to 1, then we just return 0. Because like I said, right, like this question said, you can imagine that an element is always considered to be strictly greater than a neighbor element that's outside the array. So if nums just has one element, then by definition, that has to be the peak. And now we check the second edge case. So if num0 is greater than nums1, we can just return 0. So in this case, we're checking if the first element is a peak. And the only check we have to do is to see if the first element is greater than the element that comes after it, i.e. the second element. And the second part we have to check is if the last element is greater than the element that precedes it. If this is true, we just return the index of the last element, which is right. So in this elif part, what I'm doing is I'm checking if the last element is a peak. And the way we check that is just to see if it's greater than the element that precedes it. So these are two edge cases. And let me put a comment here. So checking if nums has one element only. Oops. And this part just checks if either the first or last element is a peak. And those are two edge cases. So now we can do the binary search. So while left is less than equals to right, we get a midpoint, which is left plus right divided by 2. And here we check if this mid element is a peak. So if nums mid minus 1 is less than nums mid, and nums mid is greater than nums mid plus 1, then we return mid. Elif if let me just copy this. So if the left neighboring element is greater than our middle element, then we check the left half. So right equals to mid minus 1. And again, let me just copy this part. So now we're checking if the right neighboring element is bigger than mid. And if that's the case, we search in the right half of the array. So if that's true, then our left will be set to mid plus 1. So this is our solution. And let me just do a quick demo run to make sure I didn't mess anything up. Oh, I forgot this. Yeah. Okay, let me run again. Okay, looks good. And let me submit it. And yep, you can see that this is a valid solution, and the time complexity is O of log n. Thank you all for watching.